Hello, welcome to FEMSAM Edu Consultancy. Today we'll be looking at JUPEB past questions strictly on trigonometry, and we'll try as much as possible to put solutions to the available question on that topic. So looking at 2015, we found two questions on trigonometry, precisely theory questions. So let's see how we can put solutions to these questions. Now, 2015 question 2b is a theory question. The question says, if cos x plus alpha equal to sine x plus beta, find tan x in terms of alpha and beta. So that's the question. It's a theory question. It is expected at this time that you have all the necessary knowledge as regard trigonometry. Don't forget, we are looking at trigonometry. So you don't have to panic. This question is set under the trigonometric ratio of compound angles. So they expect you to know all the addition formula. So, and that's what we'll make use of in solving this problem. So solution. So you need to recall that sine A plus sine B, sine A plus B will give us sine A cos B plus cos A sine B, and cos A plus B will give us let's look at negative of sine first. This will give us that's sine A cos B minus cos A sine B. Then when we now have so if we have cos A plus B, this will give us cos A cos B minus sine A sine B. And if it is cos A minus B, then we have cos A cos B plus sine A sine B. All these are under addition formula. We will make use of any of these to be able to get the value of our tan x. Of course, we also have for the addition formula for tangent of compound angles, like tan A plus B and tan A minus B, and we can easily get that from the quotient of any of the two, depending on if it were to be tan A plus B, we get that from quotient of sine A plus B over cos A plus B. Then we can simplify that expression. So, but when we check what we have been given here, we see that cos x plus alpha can be applied using this particular relation. Then sin x plus beta can also be, written in this using this other relation. So this is just the addition formula I will need to apply to be able to solve that problem. I hope that is gotten. Okay, now let me go straight to, so we have cos, so now I'll start by given, we have been given that cos x plus alpha equal to sin x plus beta. This is what we have been given. So using the addition formula to expand this, we will have, this implies cos x cos alpha minus sin x sin alpha equal to, this will give us sin x cos beta plus cos x cos beta. Oh, sorry, that's going to be sin beta. Sorry, I beg your pardon. Okay, so our duty is this. We are to look for tan x in terms of alpha and beta. Don't forget that tan x is the quotient of sin x over cos x. So the kind of manipulation we need to think of is, how do I bring all the terms of sin x together, and the terms that contain cos x, bring them together. So here I can see a term here that contains sin x. I can see another term here that contains sin x. So my duty is to look for a way to collect them together because they are like terms. Now here I can see a term, this is a term that contains cos x. This is another term that contains cos x. So my duty is to collect them as like terms. So now I am bringing cos x to this side, this particular term to this side, and I'm taking this to this other side. So it's just like saying subtract cos x sin b from both sides. And here I can do them together. I can as well say that add sin x sin alpha to both sides. So that statement I've just said, we make all of this reduce to cos x cos alpha. Then when this one comes here, don't forget we said that subtract cos x sin b from both sides. So it looks like the way we have been taught, transfer this to the other side and the sign of this term will change to negative. But actually we only use the additive inverse of this to terminate cos x sin b from this side so that it can reflect here. So this becomes minus cos x sin beta. Then I have this left here, sin x cos beta. Then if I introduce the additive inverse of minus sin x sin alpha, that would be plus sin x sin alpha. Add it to both sides. This becomes, it will be terminated here, but it will reflect here. So I have sin x sin alpha. Anyway, this is what we have just done. Bring this term to this side, the sign changes to negative. Bring this sign to this, this term to this side, the sign changes to positive. So if I compare these two terms, now cos x and sin beta, cos x and cos alpha, these two terms are bounded with the operation of multiplication. So I can easily factor out cos x. Bring out cos x from here. I'll be left with cos alpha here minus sine beta here. Equal to the same way sine x is common to these two terms. I can bring it out, I can factor it out. Sine x, I'll be left with cos beta plus sine alpha. So now, look at this. You will realize that I have been able to isolate sine x and cos x. Little by little, tan x is coming to play. So, what is the definition for tan x? You realize that tan x is the ratio of sine x. Tan x is the ratio of sine x to cos x. So my duty is to look for a way to rewrite this equation in such a way that I will have sine x over cos x. Do you understand? So look at it. So it's like dividing both sides by cos x. One side I don't have to write that, you get. If I do that, cos x will be terminated there, but it will reflect here. Take it again, look at it, because I am going to all those things, the process I want to introduce, I am, introducing them with this implied sign. The moment I divide both sides by cos x, it will be terminated here, but it will reflect here. I will have to ensure that this cos b plus sine alpha is also taken away from this side, so that sine x over cos x will also be alone. That means I will also divide both sides of the equation by cos b plus sine alpha. So now that shows that considering this equation now, I can just directly say that divide both sides by cos x into brackets cos beta plus sine alpha. What that simply means is that once you do that, the whole of this expression comes under this, while this particular one comes under this. So this becomes cos alpha minus sine beta divided by cos beta plus sine alpha equal to what? Sine x over cos x. Now that we have this, you will take note that sine x over tan cos x gives us what? Tan x. So, of course, I can now generalize because of space. Permit me to do it here. I can imply that the whole of this equation can now be written. This is sine x over cos x. Let me write it first. Tan x is now equal to the whole of this is what? Cos alpha minus sine beta divided by cos alpha plus sine alpha. Cos beta plus sine alpha. If you want it to look like cos alpha minus sine beta, and the first time here to also be in terms of alpha, don't forget that operation of addition is commutative. So that means that cos beta plus sine alpha can also be written as sine alpha plus cos beta, so that it looks like alpha beta. But whichever way, this is also correct. So this is an expression for tan x. So we have been able to write tan x in terms of what? Alpha and beta. I hope that is clear. So that's just the solution to that particular question. We still have more questions to solve in the next video.